When designing for Playdate using Pulp, you're almost certainly going to look for ways to use the crank, the Playdate's unique input method. It's not all that difficult to do, but there's some key things that you should know before you start coding your game's crank controls using Pulp script. First off, there's a few basics. Pulp is going to look for your crank control input using the crank event located in the player's code. We'll kind of go there right now real quick, and you'll see on crank do. These are one of the default events within Pulp script. Additionally, there's two default pieces of data that Playdate keeps tabs on for you. It's AA and RA. Access using the event.aa and event.ra items here. You'll see that in some of the code here. So we're going to go over that really quickly by looking at the official Pulp documentation. You should keep this on hand at all times. I highly recommend that. So this is how it reads in this spot over here. In every event, its AA and RA members will be set to the current absolute angle and the amount of change since the last frame of the crank in degrees, which is the relative angle. So keep in mind that Pulp games run at about 20 frames per second. So if you're looking to use event.ra for the relative angle, you're looking at how much the crank moves in 1/20th of a second, which may not be very useful to you depending on your game. So there's some ways that we can kind of get around that we'll go over. So we'll look at a practical example first using a prototype that I've had on hand for a while now. And we're going to explore both AA and RA within the same prototype. We're going to refresh it real quick here. So a quick explainer for this. In this prototype, the crank fills up one of 4 meters that you switch between. The crank fills up one of 4 meters that you switch between using the D-pad. There's a timer on the screen challenging you to move the meter to an unknown location, which resets randomly after you press the A button, based on a DNA helix on the side of the meter. So if we paged up and down here, you'll see that we're going through each of these meters, and then as we turn the crank, we're filling up the meter and, trying to find the sweet spot, so to speak. So we'll crank and you'll see that it starts to get to the spot that we want it to go in this little DNA helix. So because there's a timer though, the gameplay could get a little frantic. See, there's a timer in the upper corner here. So that inherently means that cranking fast should result in the meter moving faster. So we'll kind of go a little quicker, and you'll see that it moves a lot quicker if we're cranking a lot, whereas if you're cranking just a little bit, you can get that finer movement that you might be looking for when you're trying to find the right spot on the meter here. So that inherently means, that, we're going to need to do something in the code here in order to achieve that. And using some nested conditionals with event.ra, you can do just that. So first, though, we're going to take a look at event.aa. So if we take a look at this little toggle icon here, which is actually the player sprite, you'll see that it moves along with the crank as well. So as I'm moving this, what happens is that it's mimicking the direction that the crank is pointing. So this is achieved using event.aa for the absolute angle. So what it's doing is it's looking for the absolute position of the crank at any given frame, and then at which point we're setting the player's own frame to the desired position. So you'll see that various frames here in the player sprites. We'll click over to that real quick and show you that. Here, not this one, but this one. You'll see that there's various frames here within this sprite that represent each direction. So when we hit a certain angle, then of the crank, we're telling the player to update its frame. And the important thing is that you can do this setting a frame for a sprite if you have it at 0 FPS. Otherwise, if it has an FPS to it, obviously then it's going to automatically update and animate. We don't want that. We want it to stay at 0. So let's look at how we do that in the code here. So obviously the crank goes 360 degrees. Based on that, the fact that we're having the toggle point in 8 different directions, again, if we look, 8 different directions, what happens then is that we can just do a little math, and we will be able to decide what frame we want it to update to. And the first frame in a sprite is always a 0, so it's actually 0 through 7 to get those 8 different frames. So what's happening is that I'm taking the absolute angle, and I'm saying, hey, if it's greater than 0 but less than 22.5 degrees, then it's going to be set to frame 0, and so on and so forth. So what's actually happening in practice here, we'll click back over here. What's happening then is that it's looking for a certain range, and if we look at where the crank is pointing, it's still pointing up. Then you get to a certain threshold here where it's pointing upper right and then pointing right in this section. So that way, generally speaking, as the player is turning it, you're getting to a certain mark. And now this is a good way when you want something to happen in your game that is relative to a specific angle. So that's for event.aa. Obviously, there's event.ra, the relative angle, and that's a little trickier. So for starters, we're going to take a look at the meters here, and we're going to look at these tiles. Now, there are cleaner ways to do this. When I first made this prototype a long time ago, and I did not need to make separate tiles for every section of this meter here. You could have just one template, so to speak, for each of these, because what you're doing is targeting these positions and telling them to update their frames, and we'll go over that. But the important thing to note is that for these tiles in the middle, I have to know basically how many pixels they take up. So in this case, as this meter fills up with each of these frames, it gets up to 8. And then the end ones get up to 6. 1, 2, 3, 4, 5, 6 here. So that little bit of math, we'll do a little bit of math, and we'll know that with 2 end ones, and then 11 in the middle that are 8, so that's 88 frames, and then the 2 end ones is 12, so obviously that means that 13 of these tiles styled in this way gets you to an exact 100, which is really nice for doing that math. So we'll go over what that means then, but the gist of it is that similar to what we're doing with this, where we're telling something to update its frame, we're doing the same thing then down here. Now, there's 2 different things going on. First off, we're doing event.ra for the relative angle, and we're going to be updating some variables in here. And then we're going to be calling this event, which is bar 1 check. This is for specifically targeting the first bar here, and I've got 4 different events, right? So if we're hovering down on bar number 2, it's going to tell that event, and so on and so forth. So when we go back in here, we'll go to bar 1 check. Let's just take a look at that event over here. Easy access in the drop down here. What's happening then is that it's doing a little math on our behalf. So as we update a specific variable, in this case it's the bar 1 variable. I didn't need to do it this way, but just pretend it's bar 1 instead of bar 1 math. Again, there's cleaner ways to do this. What's happening is that it's taking a look at that number. It's seeing if it's greater than or less than each of these numbers' maximum amounts, so to speak, for their number of frames. And then it's doing some math on the back end here. See how it's just ticking down the math, and it's updating and telling each of these frames. So 3, 5, 4, 5, 5, 5, for example. If we hover over these spots, you'll know that this is tile 3, 5, tile 4, 5, tile 5, 5. I'm telling these tiles to update what frame they should be on. So it gives this illusion that as you're scrolling up and down, what we're doing is we're telling those tiles to update which frame they should be on, and that's how you get a nice smooth meter that's moving up and down by updating those frames. And it looks smooth in here, but even on device it looks very smooth as well. So even when you're doing a lot of math and you're telling a bunch of tiles to update their frames, or even doing swaps, little less so with swaps, you are still going to have a pretty nice performant style going on here. So that is the gist of how that works as far as within these bar 1 events. But we need to figure out how to do that with the crank. So what's happening then is as you're cranking, we'll go down to this specific section. What I have it doing is the relative angle. Once you use the crank on that frame, the game is going to look for your relative angle and compare it to this variable that I call crank mod. What is crank mod? So I've got a couple variables here, but what's happening is that I have crank mod this way, and I've got a crank mod in reverse up here. Well, what's happening is that it's just a 1, and it could be 0. It'll work just fine either way. But what you're doing is you're checking to see if you're moving forwards or you're moving backwards. So if we go down, there's a whole backwards section here too as well, if you're looking then less than. So if your relative angle, if you're seeing that the crank is moving backwards a certain number of degrees, in this case at least 1 degree, then what the game is going to do is it'll know that it's moving backwards versus if you're cranking forwards. So that way we can have this up and down motion. So you have to do both. And then within that comparison, what we'll do is if it's moving up a certain amount, and we'll go back up to this guy over here, it's looking, in this case, to see if we're on tile the Y position 5. So same as that, that'll tell you that we're right here. So that way it should affect bar 1. What it'll do is it'll tick up that bar 1 variable by 1 as I'm cranking. And then it will call that event that that custom event that we did earlier. Now, that's the simple way of doing it, where you would just be able to then move up and down, because then vice versa, the backwards crank would then take it down by 1 as long as it's greater than 0, and similar to that, as long as it's less than 100 for this one, right? That would be the simple way of doing it, but like we talked about before, if we're talking about something frantic and you want a little bit of variability where you can do a little bit at a time, or you want it to go faster as you crank more or you crank faster, the idea is, what is cranking fast, right? What that means is that in a short of an amount of time, you're covering a greater number of degrees in your cranking. That's the idea behind whether you're cranking fast or slow. If you're cranking really slow, let's say in a single frame, you're only moving a few degrees at most, that would be considered slow cranking. So that's why we use event.ra in order to tell if you're cranking fast or slow. So using these nested events, you'll see that what we're doing is we're starting out slow, right? We're starting out with, are you moving it at least 1? Okay, if you're moving it 1, we're going to tick this up 1. Okay, what if you're moving it a little bit faster? Now, this if conditional is only going to trigger if in that single frame you're cranking at least crank mod x, right? Well, let's take a look at what this crank mod x variable is. We load it in inside the game's load event here, and crank mod x is 15, so 15 degrees. And you can get the idea then what we're doing here. There's x2, x3, so cranking forward at least 15 degrees, the next step being 30 degrees, and the next step being 60 degrees, which is a decent amount of cranking. And that's something that you would just be able to toy with what those numbers look like. For this game, for this prototype, it actually works pretty well. So if you're cranking, at least in this case, 15 degrees, then it would go tick it up another 1. Okay, 30 degrees, another 1. 60 degrees, another 1. So what's happening then is that as you're cranking, it's only going to do, if you're not hitting that threshold, it's only going to tick it up or down just 1. And obviously then it'll tick up even more if you're cranking more. So that's how you implement a little bit of variability, a little bit of speed, so to speak. So that way it's taking that, adding it up, and then calling the event. Very simple. That's the best way to use, in my experience, to use event.ra in order to get a little bit of speed accounted for in your cranking. So this is just one example, and there's still more that can be done with the crank using these methods as building blocks. I plan to cover that in another video, so stay tuned, and thank you for watching. Please drop a comment below if you have any questions or things that you think I should cover in the future.